This is reserve problem number 12 in chapter 6. It's a design of experiments with two factors. Rocket Sci uses two main ingredients to make rocket fuel, used to power rocket engines for space missions. They are ammonium perchlorate powder, the oxidizer, and fine aluminum powder, the fuel, held together by a binder of petroleum-based rubber. The company wishes to test the fuel mixtures in a prototype engine with a high and low level of ammonium perchlorate and a high and low level of aluminum powder. Rocket Sci wishes to use or set up a 2x2 experimental design to determine which is the ideal combination of high and low ingredients to produce the maximum thrust level. So obviously they want the thrust to be as high as much as possible. So we will look at the data that the book has, or the author has, provided for this problem. So we can see that there are two factors in this problem. Those factors are factor 1, ammonium perchlorate, and factor 2, aluminum powder. Each was set to two different levels to perform the experiment, so low and high. So ammonium perchlorate at low level was 15 grams of it was used. At high level, 30 grams of it was used. And similarly for aluminum powder, 75 grams of it was used to assume a low level, and 95 grams was used to assume a high level. So in this case, because we have two levels and because we have two factors, the ammonium and aluminum powder, that's a 2x2, 2x2, which essentially means a 4 treatment design of experiment. So the four treatments are when ammonium perchlorate or factor 1 is set to low, and factor 2 aluminum powder is also set to low. When that combination was used, so that's like this being 15 and this being 75. And then this one is high, so 30, and aluminum is still low, so that's still 75. And then this one again is low at 15, and when it's high it's 30. But then this is the 95, 95, and 95. So when these combinations of these two products were used, ingredients were used, then the thrust measurements were different, right? So these thrust measurements were 60, 103, 75, and 89. So we want to conduct this test and see what our outcomes are. For this problem, I will go ahead and use the template that the author has provided. You can see that I've already inputted the names of the factors. The low level is 15 grams here. And for high of ammonium perchlorate we have 30 grams, then 75 grams and 95 grams for aluminum powder. The thrust levels that were recorded were 60, 103, 75, and 89. And these numbers I got from the previous sheet that I showed you. As you enter these, notice that these pink cells and the chart gets populated. So you can click on these and you can see the averages or the calculations that were used to perform these calculations. They're simple enough that you can do it yourself, but this template is already set up and designed for us, so might as well use it. So let's understand what this means. Obviously, we can tell from the main effects. The main effects are the effects of the actual factors. So we can see that ammonium perchlorate has the highest impact on response for response of thrust. But just because this is low, the factor 2 is low, doesn't mean that we should ignore it. The reason for that is because the combination of the two have very strong interaction. So factor 1 and factor 2 are very strongly interactive together. So let's understand what that means. If we have, let's say we set factor 2 or aluminum powder to be high. Okay, so factor 2 is set to high. Then factor 1 is which is ammonium perchlorate. If we consider that it changes from low to high, let's see what the average response is in thrust, engine thrust. It goes from 75 to 89. So average response when factor 1 goes from low to high is from low to high, it goes from 75 to 89. So that's really 89 minus 75. That's the change that we observe in it, which is 14. Now, if you consider this 14 really is the main effect of factor 1, which is 28.5, plus the interaction effect, which is negative 14.5, and that happens to be exactly 14. So these numbers do match. Now, what if I'm going to erase these. What if we now consider factor 2 to be set to low? Then going through the same logic, we can see that the thrust goes from 60 to 103. So 103 minus 60 is the new outcome, which is 43. So this is when, and what happens? We went from for factor 1, which is ammonium perchlorate, it goes from low to high. So that's from low to high. 103 minus 60 is 43. So this is what the average response in thrust is when factor 1 goes from low to high. Okay, now how does this 43 again play into these numbers that we have here? Again, since we're looking at the impact of factor 1, then we're looking at its main effect. So 28.5 minus the interaction now, minus the minus 14.5, gives us exactly 43. So again, these numbers do coincide with each other. So essentially what we're finding is that, look at this, the difference is 14 versus 43. So this is obviously a better change or response for thrust or in thrust. Therefore, we can conclude that the best combination is when ammonium perchlorate or factor 1 is high, because it happened, we went from low to high and we achieved that better outcome. And when so factor 1 is set when it's set to high, and factor 2 is set to low, because this is, we achieved the 43 when factor 2 was set to low. That's the best combination that we should use in our to create this fuel for this engine type. Okay, thanks. I hope you found this helpful.